Algebra 2. This is Unit 9, and we're doing Lessons 3 and 4 today. We're going to be solving quadratic equations with complex solutions. So we already did the quadratic formula in the last chapter, and the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So let's try doing that in exercise 1, and you see that you're going to find that our solutions today are going to have a negative under the radical, but now we know how to deal with that negative under the radical. All right, so remember, first thing I have to do is everything has to be on one side, so I'm going to subtract this 7x and bring it over to the left, and I'm going to add that 10, and I'm going to bring it over to the left. So I'm going to have x squared minus 12x plus 40. And A is 1, B is negative 12, and C is 40. So I'm going to plug that all in. So I'm going to have x equals negative b, so that's going to be 12, plus or minus b squared, so negative 12 squared is 144, minus 4 times a times c, all of that's under the radical, over 2a. And a is 1. So I have 12 plus or minus, so that 144, 4 times 1 is 4, 4 times 40 is 160, so basically I have 144 minus 160, so that's negative 16 over 2. All right, and the square root of 16 is 4, but I have a negative, so that's obviously going to be 12 plus or minus 4i over 2. Now, all of these are even numbers, so I can actually divide everything by 2. So I'm going to have 6 plus or minus 2i, and that's my solution. All right, let's look at let's look at b just to practice another one. So I'm going to subtract 10x, and that will give me 6x, and I'm going to subtract 4, that will give me 11, because I need 0 on the other side. So it's going to be negative b, negative 6, plus or minus square root of b squared, 6 squared is 36, minus 4 times a is 1 and c is 11, over 2a. All right, so I got to clean up everything under the radical. 36 minus 4 times 1 is 4, but 4 times 11 is 44, so I have 36 minus 44 is going to be negative 8. And then I simplify the negative 8. And negative 8 simplifies to 2i radical 2. Okay, if anybody got lost on that. So it's radical 4, radical 2, radical negative 1. The radical 4 is 2, and the radical negative 1 is I. And that's all over 2. And then I can simplify that. So it's negative 3 plus or minus I radical 2. And there's my answer. All right. Something else that I want to talk about is the discriminant. So this is kind of important. The discriminant is the part under the radical. You can see that the number under the radical, so basically I'm talking about this part right here, that b squared minus 4ac, that tells me about the solution, what's going to be true about the roots. If the number under the radical is negative, then I have imaginary roots, because I'm going to have an I there. If the number under the radical is a rational number, a perfect square, then I'll have rational roots. And if the number under the radical is not a perfect square, then I have irrational roots. All right, so the piece of the quadratic formula that the number under the radical is called the discriminant. The discriminant is the b squared minus 4ac part. The piece of the quadratic formula describes the type of roots the x-intercepts a quadratic function will have. When will the roots be real? If b squared minus 4ac is greater than or equal to 0, then the roots are real. The roots are imaginary or complex if b squared minus 4ac is less than 0. All right? The roots or the solutions will be rational if the discriminant is a perfect square. Like if I had something like radical 25, that would give me rational roots. They're going to give me irrational roots if the discriminant is not a perfect square. example of that might be like radical 48. That would give me irrational roots. And there'll be equal roots if the discriminant equals 0. All right, and obviously if the discriminant is less than 0, then that's when I'm going to have my imaginary root. So if the discriminant is negative. All right, so let's look at this discriminant on the next page. So for each of the following quadratics, we want to calculate its discriminant, its roots, and state the number and nature, whether they are rational, irrational, or imaginary roots. All right, so I'm just looking at the b squared minus 4ac part. So if I'm looking right here, a is 1, b is 3, c is negative 10. So b squared is going to be 3 squared, which is 9, minus 4, times a, which is 1, and c is negative 10. Well, negative 4 times 1 times negative 10 is 40, and 9 plus 40 is 49. All right, so let's look at the roots. The roots, we already did that, that middle part. So negative b plus or minus, I already did the b squared minus 4ac, and I know it's 49 over 2. So basically that's going to be negative 3 plus or minus 7, because radical 49 is 7, over 2. So negative 3 plus 7 is 4, and 4 over 2 is 2. And negative 3 minus 7 is negative 10 over 2 is negative 5. So here are my answers, 2 or negative 5. So how many roots do I have? I have 2 roots because I want to know, state the number and nature. So I have 2 unequal roots, and they are rational. Okay, so I'm going through each scenario right now. The first case was when the discriminant is a perfect square. The next case is going to be the discriminant is not a perfect square. So again, a is 1, b is negative 6, c is 7. So b squared, negative 6 squared is 36, minus 4 times a times c. 36 minus 28 is 8. Well, that's the part that's under the radical. So my roots are negative b, 6, plus or minus radical 8, okay, because this part is, that's my b squared minus 4ac, over 2a, and a just happens to be 1. So this I can simplify under the radical. I have 6 plus or minus 2 radical 2. Radical 8 simplifies to radical 4 and radical 2. And then, of course, this simplifies to, I can cancel, these are all even numbers. They're divisible by 2. 3 plus or minus radical 2. So I have 2 unequal irrational roots. And then my last case, my last, well, not last, second to last, sorry, is when the discriminant is equal to 0. Okay, so let's see what happens here. B is negative 10, C is 25. So b squared, negative 10 squared is 100, minus 4 times a times c. And negative 4 times 25 is 100. 100 minus 100 is 0. All right, let's actually do the quadratic formula. So negative b, 10, plus or minus the square root of 0, right? So this is my b squared minus 4ac. I'm doing it separate, and then I'm doing it inside just so you can see how the discriminant is going to tell us about the roots. And this is just going to be 10 plus or minus 0 over 2, which is just 10 over 2 and 10 over 2. I get 2 equal roots because it's 10 plus 0 divided by 2 and 10 minus 0 divided by 2. But both of those give me 5. So I have 2 equal rational roots, or 1 double, because it's matching, rational root. And last case is when the discriminant is less than 0. So a is 1, b is negative 8, c is 20. So b squared, negative 8 squared is 64, minus 4 times A times C. So 64 minus 80 is negative 16. Okay, so my roots are x equals negative b, 8, plus or minus radical negative 16 over 2 times a. 2 times 1 is 2. So this is just going to be 8 plus or minus 4i over 2, or 4 plus or minus 2i. So you can see I have two unequal imaginary roots. So if the number under the radical, the b squared minus 4ac, if the discriminant is less than 0, my roots are imaginary. All right. So I want to use the discriminant in each of the following quadratics to determine whether it has an x-intercept or not. All right, so I'm just doing the b squared minus 4ac. The problem's got onto the next page. Sorry about that. So b squared, negative 3 squared is 9 minus 4 times a times c. So that's 9 plus 40 is 49. Does it have x-intercepts? Absolutely. Okay, because it actually has roots. B squared, 6 squared is 36 minus 4 times a times c. Well, 36 minus 40 is negative 4, so those are imaginary roots, so they do not have an x-intercept. So anything that has imaginary roots will not have an x-intercept. And the last one here, b squared, 3 squared is 9 minus 4 times a times c, and 9 minus, that's 8 times 5 is 40. Again, no. So if the roots are imaginary, there's no x-intercept. That's important to remember. All right, exercise 3. Which of the following one graph would not cross the x-axis? So basically, I'm looking for something that has imaginary roots. So I'm looking for a number under the radical is negative. That's what I'm looking for. I'm looking for a discriminant that is less than 0. All right, so I just sort of have to test each of these out. B squared is 25 minus 4 times a times c. Oh, that's going to give me positive, so that's okay. B squared is 1. B squared, negative 1 squared is 1 minus 4 times a is negative 1 times c. Well, that's a positive also. Look at 3. B squared, negative 4 squared is 16 minus 4 times a times c. Oh, that one's going to give me a negative. All right, so if the discriminant is less than 0, I have imaginary roots, and it will not cross the x-axis. You can always plug it into the graphing calculator to look at it as well. All right, and by using only the discriminant, let's determine the number and nature of each of the following quadratics. So let's just do this first one here. B squared, so I'm only using the discriminant. B squared minus 4ac. 7 squared, 49 minus 4 times a times c. Well, that's 8 times negative 4 is 32. 49 plus 32 is 81. So there are two unequal, real, rational roots, because remember that's under the radical right there. All right, if I had something like b squared, negative 8 squared is 64 minus 4, a is 1, c is 25. Well, that's 64 minus 100, so that's two unequal imaginary roots. And let's just do c right here. B squared, 4 squared is 16 minus 4 times a times c. Well, 16 minus 16 is 0. When I have 0, it's one double rational root. Okay, and we're going to practice all of that tomorrow.